to this computer. Okay, so welcome everybody to our, what is this, September 2020 JavaScript New York City meetup. It's been a few months, but we're back into it to hopefully get started and get revamped up. I was hoping that we would have a different world by now. Maybe things would open up, but that's not the case. So we do the best of what we have. So a couple of quick notes. First, I'm looking to do more of these. So the more, if anyone has anything they want to talk about, get in touch. If anything that you want to hear about, get in touch. Is there a new project that you're working on, a cool new company that you're starting? Get in touch and we can organize it. We're also looking for people that want to learn. I would like to organize a hackathon, but hackathons are notoriously difficult. I've organized a few here and there through the meetup, and they're, online. I think will be interesting. So maybe we'll give that a shot. And we do have a sponsor actually that will be helping. So for those that are interested in jobs, they'll be reaching out, I hope. It's Oscar, which is the first health insurance company that's built to make healthcare easy. They're in New York. So for those, I assume most people are in New York, and they've been around since, I want to say 2012, trying to make seamless support for people navigating the healthcare. So they are looking for people that are looking for roles. So I'm going to post the link in chat, and I'll also send it out after the meetup. So let me post that. Sergey, how to propose a presentation? Just get in touch with me. I put my email in chat, or you can just get in touch through Meetup as well. As far as any requirements, well, let's let our three presenters, Kevin, Paul, and Tom, show us what they've done. So with that, we are going to have three presenters. They'll have approximately 25 minutes each with 15 minutes Q&A. That may be interspersed, so they're not opposed to you interrupting them. So if you need to do that, please do so. If you want to post in chat, you can do so, and I will try to keep track of questions there as well. So quick intro about Kevin. So Kevin is the CTO at Kitemaker, which is a new issue tracker. But his talk is actually about something that I think is cool, text editing with Slate.js. So I won't give too much more away. Kevin, the screen is yours. I'll go on video and.
All right, I'm going to try this. I'm using, it says screen sharing is disabled for me.
Give it a shot now.
There we go, cool. I'm going to do my whole screen here, I hope. Let's see what happens.
Kevin, just a heads up, at the 25-minute mark, I will either ping you through chat or maybe I'll just come on and let you know with voice. Does that work?
Sounds cool. I'm getting one security warning from, I'm going to have to quit and come back because Zoom is telling me I can't share the screen without me doing that. Be right back.
All right. So while Kevin comes back, I will do some freeform jazz improvisation time filler. What can I fill it with? Oh, geez, I just went blank. Does anyone have anything to help me fill the time?
Maybe you could take a polling of like how many people would be interested in joining a career fair that you can hack together. I would definitely be open to that. And
here I wanted to do a magic trick.
It wouldn't be a proper VC thing without some technical difficulties, but it's. I'm going to see. Can everyone see my slides? I'm trying to use Pitch for the first time ever to give a presentation. Can you guys see the slides? All right, cool. Yeah. Very good. So this is a bit of a technical experiment within this thing. All right, yeah. So I'm Kevin. I'm the CTO at Kitemaker, as we just mentioned. I'm based in Norway, so I'm very much not in New York. It's a little after midnight here, so this is a pretty interesting experience to be talking to a bunch of people I can't really see at the moment. A little after midnight, but we'll give it a go. I live in Oslo with a small army of red-headed Vikings you see in the bottom corner there. Before I started Kitemaker, I did a bunch of other things. I worked with WebRTC for a while. I built a Firefox OS phone, which most people cannot say. No one bought it, but I built it. And back in the day, I was a C++ programmer. I worked on the Qt framework for anyone who's done any C++ developments. I'm going to start with a demo because I want to give people an idea of what is possible with Slate, and then work my way backwards to how that was, how it was built. So shameless self-promotion time. This is Kitemaker. This is the issue tracker I'm working on. We built this thing because basically we hated using all the issue trackers that were out there. They didn't work very well for our needs. They're kind of slow, clunky, not very much fun to use. And they didn't work the way we wanted to work as a remote team working asynchronously. So we made it really fast and nice to use, first of all, like lots of hotkeys for assigning and labeling and whatever, the typical, now typical kind of command palette to do stuff. So that kind of gets over the clunkiness factor and makes it nice to use. But what we really spent a lot of time on was making the issues really rich documents, because we think that's a really important way for teams, especially remote teams, to work together, to write lots of stuff down, to work together on discussing what to build, how to build it, work through their problems together in these issues. And so we built this issue screen with Slate.js that I'm talking about today. And it can do all the things you would want from a nice editor, right? We've got like, you can hit slash and figure out all the stuff you want to insert, like Figma designs and code blocks with syntax highlighting and all that kind of jazz. And it's got, you know, the markdown shortcuts that you'd want and all that kind of thing. And it's all built with Slate. It works really nicely, I think. Yeah, and it's we're finding that teams really do put a lot of content into these issues once they get kind of a nice editor to work with. So let's talk a bit about how we built that thing and what Slate really is. So Slate's a framework for building rich text editors. It's basically three pieces. One is a document format, like the JSON blob that represents what a document is. It's some ways to hook in React code to render that document. So basically to say, what does a headline look like? Or what does an image look like? Or what does a code block look like? A way to hook in some React components and actually render the stuff. And then basically it's a way to handle input from the user and various API calls. So what's going to happen when the user types these things? Why did it turn into a headline when I typed pound and then a space? This kind of stuff. Some might ask, do we need a framework for this? Not everyone uses one. Some people roll their own. You've got good old-fashioned content editable divs. You can listen for all the events that happen in JavaScript land and try to maintain some state in React and keep these things in sync with one another and basically roll your own. And I think some larger companies at least have done this. I wouldn't really recommend it if you're not a huge development team though. Content editable, for one, is notoriously flaky across browsers and across platforms. It behaves differently everywhere. So let someone else handle that nightmare for you. And a lot of the work you'd be doing to keep state in sync from the DOM and the data in React, you'd basically end up rolling your own version of Slate.js anyway. So just pick a framework. It doesn't have to be Slate, but I wouldn't go down the road of rolling it yourself if you can avoid it. Why did we pick Slate of all the things out there? There's a lot of choices in this area. There's Quill.js, there's Tricks that was made by the guys who make Basecamp, CK Editor, a bunch of other tools. Why did we pick Slate of all of these? The most important thing is the first one here, and that is it's got very little opinions about anything, basically. It doesn't care what your documents look like. It doesn't care what you put into them, if it's headlines or images or code or Figma designs or whatever. It does not care. It doesn't have any built-in visual stuff. There's no toolbars that come along with it and these kind of things. And that was important for us because we wanted it to look exactly like we wanted it to look. It doesn't even do undo and redo by default, actually. Like it does nothing out of the box. Was that a question or forgot to mute? There we go. Yeah, so it does nothing out of the box, basically. It's the people who made it with React in mind from the beginning. So it's really easy to just hook into it if you're a React developer and get going. It's got the basic building blocks for collaborative editing, meaning two people editing the same document, or two or more people editing the same document at the same time. So it's got these kind of primitives that you can send over the wire and keep documents up to date. It doesn't have all the functionality you need for that, but it's got the primitives. And it's got a really vibrant community. You can go onto Slack and you can ask questions, and people are super helpful and nice. So all those things together made us pick it. Showing a little bit about how Slate, this, as I said, one of the parts of it is kind of how does it represent a document? And the answer is it's really simple, actually. It takes a lot of inspiration from the DOM, which is not a bad thing in this case. So it sort of treats everything as a bunch of nodes that form a tree, basically. The top level node, they call it editor. Below that are these top level blocks. And these are the things that are kind of specific to your domain. That's where you put your code blocks and your lists and your images and all those kind of things. It has inline elements, just like HTML does in general. And that's for things like links and things that should flow inside the text. And it has something it calls marks, which are used for styling stuff, making things bold and making things italic. And if you look over on the right at the JSON blob that's there, you can see that it pretty much reflects what's on the left. It's got two top level paragraphs. They've got some children that are either text nodes with some styling or maybe a link node. And that's about it. It's pretty simple. You can read it, you can generate it outside of Slate and pass it in. It's understandable. And that just forms a tree. So if you have like a list with lists under it and those kind of things, you'll just get deeper nested trees in your JSON blob. But it's still pretty simple and pretty easy to understand. It makes it really nice to
jump in for a
yeah,
second.
please.
Is this a rigidly defined schema, or is it extendable for different use cases?
Good question. It is the opposite of rigidly defined schema. It is as flexible, I think, as it can be. So the only requirement is the top level thing is an array of these objects. And these objects have a children property if they're blocks. And those children must either be other blocks or they must be some mixture of text and inline things like links. And that's it. So like, if you look at the JSON on the right where I say type paragraph, that's actually just my own stuff. Slate doesn't care about it at all. Where I say URL on the link or I say bold on the text, Slate doesn't care about any of that stuff. Like literally only the children property and the text property are the things it cares about. Everything else is up to me, up to the developer. So it's super, super flexible.
Awesome, thank you.
No worries. This is a whole editor in Slate. So this is how you get started with Slate, basically. If you, the first line of this React component is just creating an editor with the create editor command. It's using use memo and some stuff, but don't worry about that. Basically, you need to create an editor. You need to store this object that we just looked at on the previous screen, this array of nodes that is your document. In this case, it's a single thing with some text in it, says testing. That's it. So that's the document that'll get updated as you type. Down on line 15, you see a Slate React component. All that is, if you've done a lot of React, that's a context provider that just provides the Slate editor to everything below it in the React tree, which is really handy actually, because it means things like toolbars can always just grab a hold of the editor from the context and do whatever they want, like make some stuff bold or italic, that kind of thing. And then it's an editable component, and that's the actual editor on the screen. That's like the text area, if you want to think about it like that. And that's the whole thing. So the on change fires every time the user types something, just like it would in an input or text area, and it updates that document for you. And that's it. That's the hello world of Slates. 12 lines or something like that. But that's pretty boring. I've done in 12 lines what you could do in 2 if you used text area. So how do we make it interesting? Slate basically has 3 ways to extend the behavior. It's got plugins, like any good framework. It has plugins that customize the behavior of the thing. You can handle kind of low-level events. You can handle focuses and blurs and key presses and all those things you would expect in an input. And you can tell it how to render stuff. You can tell it, with the thing on the hello world example here, it's just going to be a div with some black text in a white box. It's not going to be very interesting to look at. But you can provide your own custom rendering to tell it to make it look a little more interesting. And here's the kind of spoiler. Having built this editor over the past year or so, like 80% of what you do when building an editor like this is look for strings to match. And if you find the strings to match, do something, right? Replace some text or delete some text or add some new blocks or whatever. But you mostly match strings. You look for like colon, name of emoji, colon, and replace it with the emoji, or you look for pound sign and a space and then turn it into a headline. Like string matching is 80% of the job. What do plugins do in Slate? They're super simple. All they do is they take some built-in behavior of the editor and they override it with your own custom behavior. There's like 10 or something methods maybe that you can override. I picked the 5 that we actually use the most in Kitemaker here. But it's things like there's an insert text function that gets called every single time a user types some text into the editor. So what you can do is hook into that, listen for the text being inserted, and then do something smart or interesting based on the text that's inserted. And all you do, you can see like this, the convention for these plugins is to name them with something, like start the function name with, but there's really nothing special. It's just a plain old function. It gets an editor in, it overrides some stuff on that object, and it returns the editor back out, and that's it. So you can kind of say like, every time text is inserted, I want to check for this particular string and do something. Or there's one called insert data, and that's like if the user pastes something or drags an image onto the editor, for example. This is also where you tell it, like we had that inline link a few slides back. This is where you tell it what elements in Slate are inline. And also where you tell it what elements are what is known as void. That's things like images and stuff that doesn't have any text in it at all, actually. So the cool thing about this is it's pretty simple, the concept, like just override functionality and then pass the editor along. And what that means is you can chain these together. You can wrap it over and over again with these plugins and compose fairly sophisticated behavior from very simple building blocks. So you would write like a plugin to handle markdown shortcuts, for example, and that's all it will do. And you'll take another plugin and you'll handle image dropping, for example. And you just keep building these little things which you can reason about reasonably well because they're small, and you compose them together into a really complex editor. Slate's got a lot of APIs. I'm not going to go into it at all for like how you manipulate the documents. You can do everything you can imagine, like inserting text, deleting text, highlighting stuff, adding new blocks, deleting blocks, splitting blocks, anything you can imagine that you'd want to do to a document, you can do. And you can use that in these plugins. And the other important thing is plugins don't care about rendering at all. They're just manipulating that JSON blob we looked at in the beginning. This is cool because then it doesn't tell me what my images or my headlines have to look like. We can share code together. I can give you a plugin that recognizes Markdown, and you can decide how should that Markdown be styled on the screen. So it's pretty cool, pretty powerful, really simple. We also do a lot of event handling, especially on key down is like the #1 thing you handle when you have to handle events in Slate. In this particular example, I'm just looking as the meta key down. That's the command key on Mac. And is B being pressed? If so, let's not type a B, let's prevent the default, and let's add a mark to tell the Slate this should be bold instead. And we do like 20 of these key down handlers maybe in Kitemaker. And the most common cases are things like this, like hotkeys, or the typical stuff you think about when you're using a good editor, like when you are in a list and you hit tab the list should indent one level deeper, right? Or if you are in a headline and you put the cursor right in the middle of the text and you hit enter, the half of it stays on one line, half of it goes to the next line, but the next line becomes just a plain paragraph. It doesn't look like a headline anymore. So these kind of things that maybe you haven't thought about that much if you haven't built an editor, but if you just go to Google Docs or whatever, you'll see all these kind of behaviors. And those are very often based on when does the user press enter, or when does the user press delete, or when does the user press tab. So it's a lot of just handle these keys and call one of Slate's many, many APIs to do the right thing. And last but not least, it's about how do you render this stuff. Slate, like I said, is built with React in mind from the beginning, and it doesn't care about any of that stuff that was in the document, but you care about it when you're rendering stuff. Basically all it does is take that JSON structure and recursively, I was going to say recursively go down, but I think it actually it goes up the tree, rendering these nodes, and it just passes it to this render element function that I've shown here, and you just do whatever you want. So in this case, I'm saying if a code element, if there's a code block in our document, let's render that as a pre-tag. Otherwise, let's render it as a div. Of course, in Kitemaker, which has a pretty rich editor, there's probably 20 or 30 React elements in this switch statement, but it is actually this simple. You just decide, okay, if it's an image in my document and it has a URL attribute on it, I'm going to render an image tag, and I'm going to set the URL equal to the URL in my document. The only gotcha here is you have to remember to take that attributes element that you see, and you have to spread it on the topmost element of your custom components. That's because Slate uses that for its own bookkeeping. It's doing that job that I talked about before of linking the DOM to this data structure that you've built, and it needs to keep track of a bunch of stuff. So if you forget that attributes, you'll have just a nightmare debugging it, because nothing will make sense. All of a sudden, things will just disappear when you're pressing keys, and nothing will make any sense. So just always remember to spread it. I think Slate warns you if you screw it up as well. But that's how you do the custom stuff. Here's a really simple example of what writing a plugin can look like in Slate. Like I said, things start with by convention. So this is just a thing that's going to look for the user typing backtick, 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 and turn it into a code block for us. So we're overriding the insert text function because we want to see when the user has inserted some text. That's what's happening in number 2. In number 3, we just grab the text at the current selection, like wherever the cursor is. You don't have to go and look at the details of Slate's APIs, but we're just grabbing the current text. We're checking, is it backtick, backtick, backtick in number 4. In number 5, we are deleting the 3 backticks if it is in fact 3 backticks, and we're setting it to be a code block in number 6. So you just write these things over and over and over again, very similar to this, looking for the different things you're looking for. And of course, you build abstractions for matching these strings and all those things, but it is really simple. It is like just basically this kind of string matching 80% of the time. And you just write a bunch of these things and wrap them all together. Some stuff is hard. Those kind of things that I just showed right there is easy, but some stuff is hard. Copy and paste on the web sucks. It's terrible. So you highlight some text from a different document system and you hit copy, and a bunch of HTML ends up in the clipboard. And then you hit paste into your editor, and you have to somehow turn that into something sensible. Some editors like Notion put really beautiful HTML into the clipboard, and they put the text formatted as Markdown, and it's great. And other tools like Google Docs just put complete nightmare crap into the clipboard, and you have to deal with it. So what we did is we just made the same document in like 5 or 6 popular editors: Google Docs, Notion, Dropbox Paper, Quip, whatever, the same exact formatted document. And we just paste it into or have a test that pastes it into our editor and tries our best to make it work. It's hard to get it perfect, but we've got it pretty good, but it's a lot of work actually. Some days I wish we just treated everything like plain text and just dealt with the fact that the formatting is lost, because it would be way easier. Like I said, out of the box, Slate doesn't know anything about even undo or redo. It does come with a plugin that you can use that does very basic undo and redo, but it's not very smart. So we've had to spend quite a bit of time making undo and redo smarter. So like when you do one of these shortcuts, typing 3 backticks and turning it into a code block, if you hit undo, it just removes the code block part, but all the text is still there. Getting those things to be kind of atomic and work the way the user would expect was a bit of work. We're actually going to open source that plugin because it's pretty handy. There's a lot of stuff that hovers over our text in Kitemaker. Like you type that / menu, for example, and it pops up with all the things you can insert. Getting those things positioned correctly over the text is a bit of a trick. Sometimes you have to worry about the native selection in the browser and things like that. It's not a joy. Yeah, sometimes the editor steals keystrokes that you meant for other things. Like I said, we loaded up Kitemaker with hotkeys. Like you can use hotkeys for everything. You never have to use the mouse if you don't want to. We like Superhuman a lot, the email clients, and we stole some inspiration from there. But occasionally the editor and the hotkeys want to fight over who gets the key events, and that can be tricky to deal with. And we've had some. There are some problems in Slate with native input methods, like the MacBook Pro touch bar, and I've also been told by some of our users some devices for writing Japanese apparently fights with our editor a bit, and this has been fixed in some PR in Slate, but not merged, and it's been there for like 6 months. So there are some rough edges, I would say. Right. So before you go out and grab Slate as your editor of choice, I would give a bit of a warning. The first thing is, like, the open source project was going really, really active towards the end of last year. There was a major rewrite. They went from JavaScript to TypeScript. They dropped a dependency on immutable JS and went to just plain JSON as the document format. It got really active, but then it's kind of slowed down. There's a lot of open issues. PRs take a while to close. Issues are not being triaged very quickly. So it could be going better, I think, the actual project. We wish we had more people working with us that we could spend time on the project, but it's not possible at the moment. Also, because of that huge rewrite last year, the documentation is lagging a bit behind reality. So there's some mystery parameters and things when you look at the APIs that you just have to sort of play with a bit and figure out what they do. And also, the latest version of Slate, this rewritten version, doesn't work great on Android, but they actually just had a Kickstarter. Some company in Canada did a Kickstarter for $25,000 to support Android on Slate, and it was actually funded. They were at $14,000 until the last day, and someone pitched in $11,000 by themselves to fund it. So Android support is coming any day now. They actually just started this past week, I think. So if you're really critical, if you don't have a native Android app and you really need it to work great on Android, be a bit wary that it's going to take a few months before that's likely to be true. That was backwards. That's most of what I had to say. I just wanted to say thanks for having me from the cold white north of Norway. And if you're interested in Slate, if it seems cool to you, we're going to write a series of blog posts about it, getting to way more detail than I was able to go into here tonight. So either follow me on Twitter or check out our blog at the bottom there and follow it. We're going to do a whole series of some of these hairier subjects like copying and pasting and some of the more difficult things, and also open source a bunch of our stuff. And then one plea as a new startup co-founder is If you've got a minute, go to kitemaker.co and check out Kitemaker. We think it's pretty great and it's getting better all the time, especially if your team is working remote. We're really focusing on making things great for remote teams these days. So it takes like 2 seconds to sign up. So go give it a whirl and let us know what you think. We've got intercom down in the bottom right corner and a feedback form if you just hit Command K and say send feedback. And we're pretty quick to respond, and we're pretty quick to take in features if we think if your requests are reasonable as well. So check it out.
Cool. Well, this would be the time where we applaud. So
virtual applause.
I know that it's very late for you.
Yeah, I know.
Open sort of questions. One thing that I have is I actually was working on a project recently, and I evaluated Slate, but actually moved to Quill instead.
Yep.
Is there any reason that you found Slate to be better than, let's say, Quill or Draft or something?
Not really. I was kind of hooked on Slate early because the landing page, the guy Ian Storm Taylor who wrote it originally, I think he's one of the founders of Segment actually. He wrote his kind of philosophy for why he built it in the first place, and his philosophy just kind of clicked with me. And it was really about this like super unopinionated about everything way, and trying to make it as like lean and mean as possible. And that kind of clicked for us. And so we tried it first, and we actually very early on had a collaborative editing prototype going, and it worked really well for that because it had these sort of primitives, and it worked. So we didn't really look much further. We played around with Quill and with Draft, and we looked at tricks when Basecamp released it, but it was very opinionated. And so we just sort of, we stuck with what worked, basically. It was not deep analysis, I would say. It's just, at some point you've put too much work into it to go anywhere else, I guess.
You already have a free plan for Kitemaker, but I was going to say, is there something I can do to bend your arm to maybe give people a free trial or something? But I think you've already included that.
Yeah, it's free. So what we do is unlimited users up to 250 issues, and we don't count the issues you import from any other tool against your quota. So if you go in and you import your Trello issues, for example, or your GitHub issues, we don't count that against your 250. But if people try it out and they're still unsure and they've gone over the 250, just ping me and we'll extend your trial, and we'll want to talk to you about why you're unsure, but we'll happily give you a little more time to make sure you're getting the value that you need out of it.
Cool. We'll open the floor. Anyone have any questions? Anything they want to know more about? I can't stress enough how really awesome this presentation has been, because Slate, it's awesome, it's super powerful, but it also is no joke. So you gave a lot of warnings, which I think are also helpful.
Yeah, we have some scars. So we're actually, we're still recovering from the rewrite when they changed everything around. Like, it really changed a lot at the end of last year. All the APIs changed. He just kind of brain dumped everything he thought he screwed up on the first version, and opened it up to the community and came up with disappeared for like 6 months and came back with a fully rewritten version. And we were kind of both shocked and happy because the new version's awesome, but it was a lot of work. And we still have some things on the legacy old version we're working on. So
beautiful. Maybe another minute or two if anyone has a question.
And I'll post some links and stuff as well for helpful stuff for Slate for everybody.
So you mentioned that you were releasing the blog posts in the coming months. Does that also include the open source stuff? Sorry, I didn't catch that.
Yeah, I don't think I was very clear. We'll try to open source what we can. Things like things we've done to make history work the way we want, and those things that we'll definitely open source. We're a pretty transparent company, and we don't think we have a lot of intellectual property in our editor. So that's not an issue. The only question is like how much time can we spend making other pieces of it reusable, things like Markdown and those kind of things we should be able to do no problem. But like our Figma integration, for example, that's quite tied to the fact that a Kitemaker user has authenticated against Figma and blah, blah, blah. So there's pieces we won't be able to do. There is one piece that I pointed out that plugins don't care about rendering at all. and that key handling, like pressing keys, is separate from plugins. And that makes sharing things open source actually a little bit tricky, because we could release our Markdown plugin, for example, that knows like when you type a star and then hit space that you're building a bulleted list, or when you hit 1 and then dot and then space, you're building a numeric list. But the problem is it's not easy to pair that together with the key handlers that know how to split lists up and how to indent lists and unindent lists and all those things. So we need to think a little bit about how we do that. And of course, we're a tiny new startup, so we need to also balance that with our other work. But I will try at least to say that the things we talk about in the blog post should be open sourced.
Cool.
Awesome. Thank you.
So I just want to give an opportunity, again, being a new startup and all that. If you guys are playing with issue trackers, I have not used Kitemaker yet, but I intend to at least give it a shot. I'm coming from Trello right now for one project. So,
we have an importer for Trello and for GitHub issues that pulls in everything. So it gets all of your history, all of your assignees, labels, comments, attachments, all those things get sucked into Kitemaker from Trello, and same for GitHub issues. And the Jira one is in progress, but Jira is a beast to integrate to, so it's a bit more work.
What about GitLab issues? Someone's asking.
GitLab issues is also on the pipeline. We're just waiting for the first company that sort of says we would use Kitemaker, except you don't support importing from GitLab issues. We haven't found that company yet. So if you're that guy, then we can make GitLab issues. We can make that happen.
How's the I don't want to be too specific, but how's the overall response been, and getting people to use it? I feel like you probably, I don't want to say benefited, but COVID probably has pushed this sort of work to the forefront of people.
It has, and we did benefit in some ways from COVID. Like we had teams coming to us who were going from post-it notes on the wall, and you can't do post-it notes on the wall when you can't go to work. And that's
my screen.
Yeah, and so we did in some way benefit. It's tricky, like the cycle on these things. The way it usually works is someone tries it. If they like it, they take it to their team. The team will try it out, and if they like it, then they finally have to take it to someone who will pay for it, basically, in the company. So that's the kind of cycle we're working on, and we fail at each step. Like we drop people at each step along the way, but we're pretty happy. Like we're finding because the editor, for one thing, is really good. Like we have, for example, you can put math expressions in there, like LaTeX math expressions, and so teams doing ML have been picking it up and putting their math in the issues. And we're now thinking a lot about how do remote teams work, and particularly how do asynchronous remote teams work, like where people can't take a Zoom meeting every 5 minutes to discuss something. How can we make it really killer for those teams? So that's where we're spending all of our effort right now, basically, is thinking about those teams that maybe aren't online at exactly the same time, or where a developer just wants to put his head down for 3 hours or her head down for 3 hours and not get interrupted. How can we make this sort of optimal for these teams, and where managers can't sort of flutter by the desk and ask how things are going, and these kind of situations? How can we make it really great for these teams? So that's where we're spending a lot of our time, and there's no shortage of teams who work like that now, either by choice or by COVID. So,
well, thanks so much, Kevin.
My pleasure. Thanks for having me.
You to stick around. I don't expect you to, given that you should probably get back to bed. Recording will be available. I'll share with you on Twitter, email.
I'll hang out for a bit anyway.
Yeah. So
thanks so much.
We have Paul Copplestone, CEO and founder of Supabase. So this is super interesting because they label themselves as a Firebase alternative. So for those that are interested in rapidly deploying something, I found Firebase to be a great way to do it. The problem, of course, is the proprietary nature and vendor lock-in. So I will leave it to Paul. Are you able to share your screen, Paul?
Yeah, let me try.
And you're cool with people just interrupting to ask questions, or do you want people
to just sing out. I wish I had a presentation like Kevin, well prepared, but tough act to follow. I'm just going to do quite a demo, and I'll talk through what Supabase is And feel free to just jump in at any point and ask questions. So first of all, a bit of an introduction for me. I'm actually dialing in from Singapore, so it's 6 a.m.-ish my time. We are, Supabase is an open source Firebase alternative. So what we do is we're implementing the features of Firebase using open source tools. If the tool, we try to go with an existing enterprise grade open source tool. If it doesn't exist, we'll build it ourselves and then we open source it. So that means that we do things a little bit different to Firebase, but overall we're bringing if you've ever used Firebase, one thing you'll know is that it's really easy to use. It's really a great product. So we talked to a lot of engineers at the start of this year. A lot of them wanted to use, for example, Postgres, but they didn't. They simply just went with Firebase because it was just so easy. So our goal is to make open source tools as easy to use as Firebase. So here we are, we've got Supabase. So yes, we're open source Firebase alternative. We started this year, so we're very new. We're backed by Y Combinator. We just went through the first remote batch of Y Combinator, which happy to answer any questions about that experience as well, if you want. Yes, we're a fully remote team, so we're distributed around the world. There's about 8 of us at the moment, so still small, but about to start hiring quite a lot, especially cloud engineers. I know this is a JS meetup, but if you want, feel free to check us out and apply. We will be hiring quite a lot over the next 1 year. Okay, so what I'm going to show you is a demo of how to deploy a Slack clone. If you use Slack, which I assume everyone here has used Slack before, I'm going to show you how to build or deploy a very basic Slack clone in less than 2 minutes and using our system. I'll obviously go a bit slower so that I can explain all the tools. So first of all, I'm going to show you a few things that you can do with Supabase. Once you deploy, you connect to your database, but don't even think about it as a database because we make it very simple. So you can do things like reading and writing. In fact, I'll scroll down. So we handle the deployment of your database. Then we do a whole bunch of stuff in the middle. And all you need to do is build real-time apps. So you can do many things. You can get your data from your database using sort of like a GraphQL if you've ever used it. You can listen to your changes in real time. So any changes in your database will get sent to your browser. Creating, updating, you can use TypeScript. You can even install, if you use something like, let's say Webflow or just an HTML page, you can use it directly on the page. And yeah, so I'll jump into a demo. So once you've signed up, you just sign in with GitHub. You're presented with this screen, which is your projects page. And then you can choose, after you create an organization, you can choose to deploy anywhere in the world. And what this is doing, this is starting a project, but we're actually giving you a full Postgres database. We're in alpha right now. We've only been building, everything that you see has been built in 6 months. So that means everything's free as well, because there's bound to be bugs. Hopefully not during this demo, but if you spot some bugs, just punch it in the feedback up here and we'll fix it up. So I've already started a project here. The first thing that you get presented with is this query editor. Now don't worry about this because pretty soon we're going to have a table view, which actually I'll show you once we have some data. But the query editor, you actually can query your database directly from here. You don't need any other tools. You can just do everything from the website. The website's app.supabase.io. So I'm going to do one. And here I just clicked on a quick start template called Slack clone. And what I'm going to do is deploy a few tables. And then we have a link up the top here, which I'm going to go to. So first of all, I'll just run that. And you can see success, no rows returned. What that has done has created a few tables for me. And now I'll show you the table editor, which looks
I can
similar
interject
to...
for a quick second.
Yep.
So Firebase is document oriented, right? So there's no schema.
Yep.
I might have just missed how that corresponds to Postgres here.
Yeah, so yeah, you're correct. Firebase is a NoSQL store. We haven't made the exact same technological decisions as Firebase, but on purpose. So one of the things that you'll find if you search for Firebase online is that people love it. It works really well until it doesn't, basically. It gets to a point where it doesn't scale very well. And not scaling very well actually means a few different things. But technologically, when they first started, they were using MongoDB, and Mongo is quite young. So at the start, it meant that it just literally could not scale in terms of technology. We've chosen Postgres. It's completely open source. It's as open source as you can get. But what happens is if you migrate away from Oracle, you go to Postgres. So you can be confident that if you're using Postgres, you probably will not have to migrate off almost ever. You might have to do some things around sharding and everything. But yeah, because we know that it can scale, then we chose Postgres. And we're just choosing one of the best tool out there, the best open source tool. Now, our goal then is to make Postgres as easy to use as a NoSQL store. So as an example, here is one of the ways that we do that. You can set up, for example, tables like you would on a spreadsheet. You can import some data from a spreadsheet. You can upload a CSV, and that will create your tables for you. Postgres is a relational database. So for example, these messages here, in this table, they obviously belong to a certain channel. So you can actually dig in, you can open this message, then you can dig in, and then you can see which channel it belongs to. So you can dig into your relationships. And we're just making it extremely easy to use. And that means that you can be confident that in the future, you'll just never have to migrate away. Cool.
So I was gonna say, I have a kind of follow-up that I guess is probably related, but the choice of not using SQL, but using something SQL-esque, is this also a sort of usability factor, or is it something more than that?
Sorry, not using SQL. I assume
Didn't you say
you mean we use SQL. So actually,
okay.
What you're seeing here is running on the Postgres database. And in fact, we give you, if you come to the settings, we give you Postgres level access to your database. On the front end, we give you an API. So actually, here's another very cool thing. You see that I just created these tables. I'll jump back, and you've got users, channels, messages. You'll come here, and we've auto-documented your tables. So here, channels, messages, users. I come in here, and you can see I can just copy and paste this code into some JavaScript code. This will, for example, select all the data within the channels. This will be able to select just certain columns. Now, this is auto-documented. So for example, I'll create a table here. I'll just call this demo. It's going to have some columns, some ID and updated at a JSON B column even. So you can put JSON data into Postgres. So kind of like a NoSQL if you wanted to use it like that. I'll just run that, and then I'll come back to the auto-generated documentation. You see here now it's got demo, and you can actually see that it's documented up, all the fields. And once again, the copy-paste code works for this table.
Nice.
Cool. So just to get back to the Slack clone, I just deployed.
One more, just maybe.
Sure.
So, when I use Postgres, I use something like SQLize to define the schema.
Yep.
Is that sort of step necessary here, or how does that work?
Yes. So actually, you might, if you're using migrations or anything like that, that's fine. You would just write it into your code and you'd connect to the database. Sorry if there are any new developers, don't worry about this database stuff, just because you don't actually need all the database stuff. We abstract it away. But if you are a developer, yeah, you can literally just use whatever you want with your database, and then it'll appear here. It's just a regular Postgres database that you can use. So it's fine, spin up all your schemas. I will say one thing, at some point we're going to do two-way linking between Git. So anything that happens in your dashboard here, as you're setting up your database, you just link it to a repository, and we'll actually dump the schema and all the migration files into the Git repository. And likewise in reverse as you are doing it. So we'll have an opinionated way of doing migrations at some point. We're just at the moment haven't built that out. So actually what happens is at the moment you don't need any schema. So for any tools, because we introspect your schema. So as an example, if I jump back to here, we're actually going to do this where we select, for example, if this was channels, we're going to select all the channels, and then inside it, we're going to get all the messages and the text from the messages. So this is a relationship. You didn't actually need to specify this. We just auto-detect the relationship from your database. We know that, for example, the messages table might belong to rooms or channels. So you don't actually need to do anything but set up your database. Once you've set up your database, loaded it with data, then you're good to go. So what I'll do is I'll come back here. I just copied this link, and this takes us to one of the example repos. We've got inside Supabase, we've got an examples folder, and this one's called Slack clone. And what I'm going to do is just click this deploy. This will deploy a front end, which we wrote for you using Next.js, a very basic one. I'm going to put Slack clone 2. And then it asks for two things, a URL and a key, public URL and public key. So I'll come to my settings and my API. Here is the URL. This is my API URL, which I'll put in here. And then I've got a key. One is the anon key. This one's safe to use on the browser. And then a service role key. This one you should never expose. It bypasses all security. This one sits in security rules, and I'll show you how to use security soon. So I'll deploy that. So this one, if you've never used Vercel before, basically they're a kind of Jamstack platform similar to Netlify. In fact, you could deploy this code that I just showed you on either Netlify or Vercel, but we've got a one-click deploy with Vercel. So it's just even easier. I think it's going to take around 60 seconds. So while we're waiting, I will point out one other thing, which is our security. So we don't have any users, but we're going to allow users to sign up, and we've handled all the auth for you. Then it's not only that you want users to sign up, you only want to give them access to certain tables and certain rows. So we have created this thing where we use Postgres's row level security, and you can create very specific rules. So I'll show you the rules for the messages table. This one, for example, if you, we've got a bit of a bug actually. I just need to deploy later on today, but I can't click into this. But this one here, allow logged in read access. This rule says that if you're authenticated, then you can read any message in the messages table. This one is allow individual, probably this one is more interesting, allow individual update access. This means that only the user who is logged in can update a message that they created. And so you specify the rules on your database, and you never need to specify them in your code. They'll just propagate, as long as you're using our API, they'll propagate through. You can just forget about the security inside your code. It actually cuts down your JavaScript code quite significantly because you don't have to put in where clauses and filters and things like that. You could just put a rule in here, for example, that you know, this user is only allowed access to certain on select. They might be only allowed access to certain rows. Then you can just do a select everything, and it will only give them the rows that they have access to. I can talk more about that later on if you want. But okay, as you can see, we now have the thing deployed, and this is just, I'm just going to sign up with testemail.com. In fact, you can do it yourself if you want on Supabase Slack clone 2.vercel.app. I don't know if I can put that in the chat.
If you could put it in chat, we can all chat there.
More chat. That one, I think I didn't do.
You sent that to me privately.
Okay, then
Send it out. Okay.
I'll sign up. Okay, great. So here now I've got basically a full Slack clone, a very basic one. I can create new channels, hello, and I can also write messages. Then if someone is logged in, if they're not, then I will do another one myself. But if I write in here, okay, it's also the nice thing because, well, there you go. We've got someone else logged in now, so they can actually write, hello. Great. And you can jump between the channels. So this is fully automated, fully real-time, should I say. Got a few people in. And I'll just show you now in the back end what's happening. So you can see that we've got users that are appearing. We actually handle all the authentication, all the email login. It's very, very much set up for you. And then from the table view, you can see the messages are appearing, new channels are appearing. Yeah, so you can actually dig into your data again yourself. So yeah, this is basically it right now. So we yeah, have a very nice small feature set of auth, the table view. We've got the automated documentation, the automated APIs. You can really start building anything in terms of your front end. You can connect whatever JavaScript framework you want. So you can connect Vue.js, you can use Vanilla.js, you can put it onto an HTML page, Next.js. You can, literally just use it anywhere. React Native even, you can use it there. And at some stage, very soon, we are building out more client libraries. So I'll go to GitHub/Supabase. We're building out more client libraries. So right now, the way we structured it is that it's one client library is built up of 3 separate client libraries. And each one of these standalone works with an individual tool. And we're building the official JS ones, but we've already got people contributing to the other libraries. And it's worth me pointing out because these are all open source tools, and I want to give a shout out to the tools that we use. So this is a sort of architecture drawing of all the things that we use. Kong is an API gateway, open source, very cool. And then GoTrue is built by Netlify. It handles authentication, so letting people in. Postgres is a tool for introspecting Postgres, the database, and providing the APIs. That's a very, very cool product. I recommend checking it out if you just use Postgres. We actually employ one of the lead maintainers of Postgres. The real-time server is one that we built ourselves. It's built with Elixir. It listens to the Postgres replication stream and converts it into JSON and blasts it out over WebSockets. And then PG API is one we're creating for ourselves for managing Postgres schema over a RESTful interface. Then of course Postgres, which is 40 years of technology, is amazing. It's worth checking out. And even if you've never used a relational database, I recommend getting into it and trying it out because it's just something that will make your life incredibly easy as you start to scale. Cool. So I think that's all for me. Happy to answer any questions.
That was a question about is really cool about migrating, because we're at Kitemaker. We've got we use Postgres. We've got our GraphQL API sitting in front of it. We do a bunch of stuff to try to make our thing work offline, et cetera, et cetera. How would a kind of semi-mature product think about adopting Supabase?
Yeah, good question. So first of all, we're in alpha. Our push right now is that for the next 2 months, we're going to move to beta. At that point, we'll be stable. So I'll put that caveat out there. All right, so once we're out in beta, the migration is, if you're already using Postgres, is literally do a PG dump and then do a PG restore, and that's it. You'll have everything that you just saw here. The only thing that will be different is we have a auth schema. So we handle a lot of the auth. We segment out the public schema and the auth schema so that you can't access the auth schema from the front end. So you might want to, you might have to rethink how you do, if you want to use our auth, you would want to rethink how you do your logins and things like that. Just to migrate each user. You could just do a trigger, for example, to migrate them into the auth schema. Then as well, you would want to use Postgres policies. So the auth that I showed you, the policies are Postgres policies. Very rarely used, funnily enough, but once you start using them, they're awesome. Yeah.
Cool. Thank you. We'll keep our eyes open for when you guys are out of beta.
Yeah, if you want as well, if you're thinking about doing something like this, anyone's thinking about doing something serious, just let us know. We'll invite you into our Slack, as either into the community channel. We've just got a closed Slack, or we can do a shared org, and we've got a few people doing that. And we just help them. If you've got any problems, questions, then you can just ask us directly.
Anyone have any more questions? I mean, really, this is awesome. And you kind of answered my question, but I was going to ask so I'm in the process of building something right now, and I'm using Firebase. Is it worth it right now, do you think, from a production standpoint, for me to start to build with Supabase instead, knowing that my timeline for getting my product out is probably about that 1.5 to 2 months?
Yeah, we build pretty fast. So everything you saw was 6 months of building. So I would say we'll probably beat anyone else out of beta. If you've got something that you're migrating, possibly, I can just say that probably by December we'll be out of beta. So up to you, of alpha.
I'm super greenfield, so I have the opportunity right now to switch around.
Then we'd love for you to switch in. Yeah, of course, it might take time. We had one person who converted from Firebase to, converted a full app from Firebase to Postgres. They had used Postgres a little bit before, took them around 4 hours, so it wasn't too hard. Eventually, we might write a tool as well to help people migrate live and run them in parallel. But up to you. And by December, we should be pretty stable.
So in the spirit of helping and supporting startups, since you're not charging anything, I guess you can't offer anything to the community. That way.
Hey, you, Jesus.
I mean, first of all, a couple of ways that, things that I would love from the community is from everyone here. If you want to, of course, we'll be employing people at some stage, but we're also open source. So I'd love for anyone to contribute. Follow us on Twitter, supabase.io, Supabase_IO, sorry. Then for us, what we can offer for the community is basically free Postgres databases, which I don't think you'll get in many other places. What you might find is some people are offering free Postgres, and they'll give you a schema within a database. We're literally giving you a whole server, and we're hosting all of these at the moment, and we're doing all the security for you. We've had people installing crypto miners and all sorts of weird stuff on it. So we're handling all the security and everything. So honestly, if that's a free Postgres database isn't enough to convince you, then I'm not sure what is.
Beautiful. All right, thank you so much, Paul.
Cool.
Especially given the time. I know it's not super convenient, but I really appreciate it. And looking forward to seeing Supabase grow.
Cool. Thanks, everyone.
Okay, so our last talk is Tom. So Tom's gonna be talking about something that I'm personally interested in, finite state machines. So Tom is a full stack developer in Brazil.
That's right.
All right, Tom. So I don't have much knowledge here, so I can't intro it much better. So I apologize for that. But same question, do you want people to interrupt you as you go along, or do you want to hold off, or what works for you?
That's fine. I think people can talk. I'll probably stop and address questions.
Cool. All right, we'll take it away.
Nice. Let's share my screen. Desktop 1. Let's present. Whoops. Okay, can you guys see it?
Yep. Yeah.
Okay. Hi, everyone. Thanks for having me. I'm going to be talking about state machines and Xstate, which is a pretty cool way to deal with logic and complex problems using software, using state machines, which is actually a concept. And I will explain that next. So I'm kind of glad to meet you guys. You can call me Tom. It's a nickname based on my middle name. I'm mostly a JavaScript developer. I learned to program on it, and I am building my career with it. For now, I'm also a big fan of programming, and I really like learning a bunch of things. So I enjoy learning anything right now. I work at Xteam, and those are my social networks. I use Twitter a lot. Also, my LinkedIn is on the slide. If you guys want to add me, I will appreciate that. Cool. I'd like to thank my friend Mikey for helping me with the talk. He shared with me his slides on the subject, and that was really helpful for me to, have some reference on building the talk. Cool. So state machines can help you fix a problem that is very, very common, which is complexity, right? So just doing software is hard. Dealing with business logic is hard. People requirements, they can change all the time, and you have to keep track of all these changes all the time. And like the browsers are very hard, and users, we just have a lot of problems with complexity. And state machines can help you solve that, because they can they work like a box that can house some logic, and it helps reduce the complexity that you're dealing with. So in a nutshell, like finite state machines, they are models really that will help you simulate sequential logics, like a sequence of actions that happen over time. There are software implementations that are hardware implementations. It's actually someone wants to say something? Okay. So there are common uses in hardware for state machines, like in different industries. I've heard that they are used. So you can implement both in hardware and software. And there's also lots of use in games. And an interesting keyword for it is actually state charts. You can find a bunch of interesting things on the subjects just searching for state charts. Nice. So this is a bit of a practical example of what a state machine is. You have the states in the rectangles, and then you have the arrows, which are events, and sorry, the arrows are transitions, and the events are actually the buttons being pressed. This is probably from a game, and this is basically what it is in practice. It may sound a little complicated, but in practice, it's really simple. It will basically, a state machine would be an implementation of this diagram. That's basically what it would be. Cool. So state machines have a few parts. So they have an initial state. In this diagram, maybe the initial state is standing. They have a finite number of states that are possible. So in this diagram, there's 4 states. So those are like finite. Obviously, there's only 4. There's the idea of a transition. which is the arrows here, and I will explain further how you can use transitions. And there's a limited number of events. In more formal language, mathematics, the events can be understood as an alphabet that the machine understands. Cool. So these are some upsides that I think state machines have and why they can help you write better software, right? If you use a state machine for your logic problem, and you can use this for several types of problems that I'll show several examples here, about 4 examples coming up. But one thing that I find helpful is that you have to think about all the possible states up front before you actually start coding. Another thing they do really well is to isolate logic from other code, so you don't have that spaghetti effect of having logic all over the place. Basically, your logic stays inside the machine, and it's pretty decoupled and isolated there. There's also another upside, which is events. Basically, the way you interact with a state machine in JavaScript is basically throwing events at it. So, and I think that the event-based model is pretty popular. I mean, Redux uses it. The browser deals with events as well. So you can fit this into other tools quite easily, right? Because state machines are self-contained, they also, they greatly reduce the complexity of maintenance, bugs, and things like that. You get a neat chart for free, which I'm going to show a few. So basically, if you actually code a state machine or you make a shard, you can convert from one to the other. So you can have a visual representation of your logic, which can be really helpful to wrap your head around what you're doing if it is a complex problem. It also works as good documentation, and it is framework agnostic. In this case, it doesn't matter what front-end library you use. I'll talk about React later, but you can use anyone and your state machines will work as long as it's JavaScript. Cool. And I think that the best feature is definitely that you don't have to keep track of states, events, and side effects by yourself. You can just kind of let the machine handle it for you, and that greatly reduces the burden that you have to worry about. So the result is basically that the complexity of what you're building feels smaller, which is pretty cool. So about JavaScript and the tools that we have in the ecosystem, I searched last night for both these keywords, and there's about 400 or so packages in the ecosystem. That's quite a lot. There's different implementations going around, and I'm going to be focusing on Xstate, which is made by David Kay. It's a pretty good library. It's very, very feature complete. It has a visualization tool, which I'm going to be showing. And I really like it, and I would recommend that. So what would a machine look like in code, right? Let's suppose that we are modeling a semaphore. And a semaphore means a traffic light, if you happen to not know that word. And this is the code for it. Basically, you have to write an object that defines states, and then there's a transition from one to the other. Nice. I'll be showing it in the visualizer, which will help us understand that. Are you guys seeing the visualizer all right? With the states?
Yeah. Yep.
Cool.
If it's possible, make it a little bigger, that'd be helpful, but if not, that's fine. Perfect.
Like this. Yep, that's nicer. So basically, oh, yeah, the idea here is to just show the visualizer itself. So this is what I meant when I said that you can visualize your logic. Let's get the specific semaphore machine here, because this is the one that is here by default. This is the one that I was talking about, the semaphore machine. So this is it, basically. There are states, and then there are actions that you fire to go from one state to the other. And that's basically how it works in a very simple example. So you can basically code this and understand it better by playing with it and further improve it as you play around the diagram with it. Right, so this is another example that is the default machine, this one that was open here. This one is really simple, basically to understand the idea of states and then actions. Next is like the action that you're using here. Here we have more states, and whenever we are loading, there's a decision here to be made. So either the request will resolve or it will reject. And if it rejects, then we have a failure handling here. This is actually a context assignment, which means that this machine is saving internal state. The machine has internal state, so you can actually save information to it, which is really useful to implement real world problems with it. But the way it works is probably pretty straightforward. Like if the request rejects, then we want to retry, and any code that depends on the failure state gets to run then. And if we resolve correctly, then we are in a final state. You can see here that success is a final state. And what this means is that this machine is done, and then you have to reset to basically use it again. So let's look at the code here. As you can see, it's basically the same idea from the previous code. You just define states, actions, and then states that follow those actions. Here on the retry state, you have the actions. I think I clicked, yeah. Here you have the actions that does the assignment to the context. And what it is doing is just keeping track of the retries the machine has done. And this assignment happens whenever we enter this state. So I think that's it for this example. Any questions so far?
So far, so good for me. Anyone else have any questions? This looks awesome.
Cool. Okay, let's continue then. I will stop then. Yeah, so here I talked about the done state. I talked about the machine saving context. Cool. And this is the link for the Xstate visualizer thing. If you just Google for Xstate, then you probably fall here, which you can find the links for it, and the visualizer is right here. So you'll find it if you Google for it. Nice. Let's look at another example, a little more complex, so that we can explore more what we can do with state machines and how it can help you guys write better products and code. So this one is called cat fetch. Mickey wrote this, and it's a little more. I mean, the idea is similar to the previous machine, but it has an invoke property here. And invoke is used for side effects, like you want to write something to the disk, you want to do a network request. Usually you would do the side effects using an invoke method in the Xstate library. And after we retrieve the cats, then either we are done or we have an error. So it's basically the same idea as this machine. It just has an explicit effect here, which is what I wanted to highlight, which is the side effect that happens in this state. Code for it it uses the same concepts that we already saw. You can see here the context being initialized. So this is the initial state of these fields in the machine. So there's no error initially, and there's no cats. So the cat array is empty. And then whenever we are fetching in the fetching state, then we have an invoke effect, which will fetch the cats, which probably does a network effect, or it could be any other side effect that you want to do. And this is nice because it'll be easy to integrate with other libraries and tools that are built around avoiding or controlling side effects. So this will be nice. And also I like how this object here it's kind of big, and this is my main complaint with state machines right now, that the configuration ends up looking like a bunch of boilerplate. But it isn't too bad considering that I really like the benefits of using it. But this assignment here, it is declarative, so you have to basically be very declarative in how you write your machine. So this configuration will always be very clean to read and understand what the machine is doing. Yeah, so the idea here was to talk about side effects. Cool, so let's look at a different example now, which is the idea of a video call, right? A video call. This machine looks a little different because the problem that we're modeling here is that in a video call, you have audio and video, which is like two separate states. And each one of them can be either on or off. So there's actually 4 possible combinations here, which is audio on and video on, or audio off and video on, or audio off. I think I was audio off, off, on, and then one or the other, on or off. So that's like 4 combinations. And the underlying problem here is that if we were using just one machine to represent these 4 states, if we had not 2, but like 8 possible states, then we would be doing exponential multiplication, and we would end up with a very, very large machine. To avoid that problem, we nest the machines together, and we keep track of them in parallel. So it looks really simple, like the audio can be on or off, and the video can be on or off in a call. And there's like a parent machine that has 2 machines inside. And whenever you fire an event here, this event is actually fired to all the other machines. But this one is the only one that handles it, so all the others will silently ignore it. And you can create a parallel machine or a nested machine by passing this property type parallel to your Xstate machine. And then the way to actually do it in the configuration is that the states of the parent machine, each one of them are a machine themselves. So the first state is actually another machine, which has its own states. Hopefully this isn't too confusing. Is there any questions about this?
No, I'm good so far.
Okay. Nice. Yeah, so that's it. So I just to reiterate, the idea here was to show nested machines are also called parallel machines, and what it accomplishes is to, here we have 4 possible combinations, but there could be much more combinations. And I personally find that when modeling real world problems like navigation or validating a form or something like that, usually you can have having parallel machines is really helpful. So this is a very simple example of that. This is a machine that I have in a side project that I'm building. So this is actually a machine that I wrote for my own use. So this problem has some. It is practical in the way that it isn't just to explain the basics. It's actually something that I use. And so what we're doing here is basically like a form validation. These are the steps of the form that we have, and each form each of these steps has to repeat the same logic. So this machine keeps track of the step that we're on. So right now we are getting the name from the user. You can visualize this as a sequence of forms or pages that the user is filling. So for each page, we want to prompt him to fill up and provide us with some input. And this is done by the side effect here. Whenever we get input, then we have to validate that input. And this validation can either succeed or fail. And if it fails, then we want to give the user some feedback like, hey, that doesn't look like a valid email. And then he's back to step one where he has to try again. But the nice thing is that notice that this specific event is shared by both machines. So when he actually succeeds, then the state progresses in both machines. So if he just keeps getting it right, then this machine system will actually move forward in the flow, and then we are done. Like we got all the information that we needed from the user, and we actually finished this user story, right? So this is actually the entire logic for a user story modeled with two parallel machines, right? And this one has the logic that repeats on each step. This one has the macro steps that we need to actually follow. Here is the side effect for prompting the user. This is the side effect for validating what he typed. And this is just to save the note ID from the database so that we can successfully update this note in the database. Nice. In terms of the code, it looks a little more involved than the previous ones because we are doing more things. But once you understand, there's an initial learning curve to using the library and to wrapping your head around a new concept. But it is just a repetition of the previous concepts. You know, if you understand the simplest machine, this one is basically the same idea, but just more of it at the same time. Cool. This is not a very complex machine. It's actually simple. I may have to make it more complex. This is like an MVP level machine, right? You can have a machine that is much larger than this, and any very hard real world problem like you know, a game interaction or an ATM machine, these real world problems, they would have gigantic state machines and would look much bigger.
We got a question from Sam.
Okay, let's see. Oh, I think I'm off the screen share. I'm trying to access the chat. Chat, okay. Okay, chat. 25 new messages, okay, cool.
But is there a way to visualize your machine during development?
Great question. So I know that David K is working with, there's already a DevTools for Xstate, so you can probably use it. And I think if you can't visualize your machine today, that is definitely a goal of the project. So there is the DevTools for Xstate, and I still haven't had the opportunity to try it. I have my own. I basically during development I generate this string from my code and I just paste it in the website. So that works surprisingly fine for development. So you just copy your configuration, paste on the website, and then you'll be able to visualize it. Is there any other questions? Okay, cool. So there's okay, I think that's it. Nice. That's actually it. Oh yeah, usage with React. So if you use React, Xstate can be really useful for you. There is actually a helper in the Xstate project, which is called Xstate React, which has hooks and other helpers, other cool stuff that you can use to make your life easier with Xstate. So what I would do with React is basically keep machines in their own file or folder. I would use React context to distribute them to other components. You can write a custom hook or use the hooks that there is already available hooks in Xstate. And then basically once you have the machine working, right, the workflow for me usually is I will throw some configuration on the machine and I will basically prototype my idea on the visualizer. So this helps a lot to get the logic working as you expect, and you can easily click around and see if it's working or not before you actually code it. And it's nice because from React, you can just fire events to your machine and then listen to the transitions or specific states that your machine is going through. And that's basically how it works. So you have a nice isolation here. You can also put side effects in your machine, like navigation, showing input or showing output to user saving, things like that. It works nicely. I know a friend of mine that has been using Xstate with React for quite a while, and he has a good experience with it. Nice. And that's pretty much all I have. I'll paste this slideshow in Zoom. If you guys will probably be able to access it later.
Cool. That was awesome, Tom. So this is, again, the virtual applause.
Thank you.
If you email it to me as well, I can send it out to the group at large.
Cool. Let's stop sharing my screen.
So questions. Who's got questions?
I'm sorry, can you go over again why you prefer Xstate over some of the other state machines that are available?
Okay. It is really complete and polished as a library. The documentation is really very complete. I did search for other alternatives before Xstate, but they don't have a visualizer like Xstate does. And just the visualizer is a pretty cool feature that I wouldn't want to roll without. I think that's a lot of one of the biggest benefits is having the visualizer. So I would search for an alternative that used TypeScript and had a visualizer. But if you have these two things, you may be able to find another library that offers that. I just don't remember right now off the top of my head a name or something like that.
Thank you.
You're welcome.
Cool. Do another minute or so for anyone else with any questions. Yeah, and thanks to everybody for joining, especially our speakers. I know timing wasn't super convenient for some of our speakers, so thank you for that. Thank you again to Oscar for helping with recruiting and sponsorship. And thanks to you, Tom. Great talk, and I'll be looking.
Thanks.
Oh, sorry, we got another question. Sam says, I have another. Have you built any of those larger machines? How does it scale?
This is the link for the presentation, guys. Cool.
You sent it to me privately.
Okay. Oh, I sent to you privately. Okay.
I just shared that.
Okay, cool. Thanks. So I have, this is the complexity level that the node validation machine is probably the largest machine that I'm working on right now. It's just like a side project where I explore using this library. But I have heard good things about using it with bigger and bigger problems. And I would definitely use it myself, since I think it has a lot of upsides for isolating your state and keeping it isolated. I think those are the main fundamentals there. I also really like the visualizer, and you can share this visualization with other people in your team, and it can be really, really helpful. I would definitely prefer using state machines over managing the states myself using if statements or other more manual approaches, right? If you use state machines, you can't have unexpected states, basically, and that already fixes a bunch of bugs. So I personally feel good about scaling problems with state machines. Is there any other questions?
I don't know if anyone else has any other questions. Going once, going twice. All right, thanks again, Tom.
Thank you.
Thank you, everybody. And thank you all for joining. I'm hoping to do this at least once a month, maybe more. Yeah, so I'll leave you guys to it.